I am going to welcome you to the second international conference on emerging trends in physics. This will be a 3-day conference. On the first day, we have gathered here in Ikra Auditorium at Lahore College for Women University, and for the second day, we will be gathering at Punjab University Center for Excellence in Solid State Physics. And for the third day, we will be back on Ikra Auditorium. For the first day, for the first day, we will start with the recitation of Holy Quran, and for the recitation of Holy Quran, I would like to invite Dr. Talat Zishan, Assistant Professor, Department of Physics, Lahore College for Women University.
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم الرحمن علم القرآن خلق الإنسان علمه البيان الشمس والقمر بحسبان والنجم والشجر يسجدان والسماء رفعها ووضع الميزان ألا تطغوا في الميزان وأقيموا الوزن بالقسط ولا تخسروا الميزان والأرض وزنها للأنام فيها فاكهة والنخل ذات الأكمام والحب ذو العصف والريحان وبأي آلاء ربكما تكذبان I seek refuge in Allah from Shaitan. In the name of Allah, the entirely merciful, the most merciful. The most merciful taught the Quran, created man, and taught him eloquence. The sun and moon moved by precise calculations, and the stars and trees prostrate, and the heaven he raised and imposed the balance, that you no transgress within the balance, and establish weight in justice, and do not make deficient the balance. And the earth he laid out from the creatures, therein is fruits and palm trees having sheaths of dates, and grains having husks and scented plants. So, which of the favors of your Lord you denied? Sadaqallahul Azim.
I would like to invite the conference chair, Professor Dr. Zuhra Naveed Kayani, and conference co-chair, Professor Dr. Saira Riaz, to come up on stage and take their seats. Thank you, madam. Now, We will formally start this session. Before that, I would like to invite Professor Dr. Zohra Nazir Kiani, Chairperson, Department of Physics, Lahore College for Women University, for a few welcome words.
Ladies and gentlemen, Assalamu alaikum and very good morning. I welcome you all in the second international conference in Lahore College for Women University, Lahore. Basically, this conference underlines how materials represent a very promising role to develop novel economic and environmental friendly industrial processes. And to achieve this goal, how we have to do the collaboration and how we have to see that what other national and international researchers are doing. Basically, these types of conferences are arranged for the students and the researchers to get benefited from the other researchers who are working in well-reputed international and national universities, so that we can also bring that knowledge in our university as well. I am very proud to say here that physics department is very productive department and we are conducting research in different fields. But again, there is always a room left when we have to see for the collaboration and other researchers of different universities and even of different fields. Basically, we have suggested this topic as emerging trends in physics. We are not only bound to that is your classical physics or your modern physics, basically biophysics, even your earth physics, geophysics, everything can be covered in this topic. I hope that you all will enjoy this conference, not only enjoy the conference, but learn as well, and then apply all the knowledge you have gathered here in your everyday life. Now I just want to say a few words to the students. Students, you are the future of Pakistan, and you know that in future you will be just sitting here or standing here as well. So, just three things which you have to follow, which is said by Quaid-e-Azam when Pakistan was just came into being. That is, what are those? Unity, discipline and faith. So, I want to see you successful in everyday life, but I will also expect from you that you will just note down what the other researchers are telling you about the research, as well as you will also share your knowledge with the already other universities as well. Stay blessed and enjoy these 3 days of conference and get knowledge as well. Stay blessed.
Thank you so much, Madam. As the patent chief of our conference, our Vice Chancellor couldn't make it today, but hopefully she will join us on the closing ceremony. But she has given a video message to our students. Let's listen to her.
Bismillahirrahmanirrahim. Assalamu alaikum. I welcome you all to the second International Conference on Emerging Trends of Physics. I must congratulate Dr. Zohra Kiani and her team, as well as their collaborator from Punjab University, for organizing this conference. It is definitely need of the hour, and I am confident that this conference, like the first international conference organized by the same team, will be a huge success. I wish you all a very productive time during this conference, and I hope that it will be a great opportunity for our young researchers to learn from their senior colleagues as well as to develop research collaboration for long-term research projects. I wish you all a very productive time and thank you very much.
Thank you, madam. Now, our chief guest, who was supposed to be here with us, but but it was difficult for him to make. But our chief guest who was planned to be here was Professor Dr. Shehzad Naseem, Professor Emeritus at University of Punjab. Professor Shehzad is an exemplary researcher and educationist. He is currently serving as at the Center for Excellence in Solid State Physics. He has a vast experience of more than 35 years as a researcher and educationist in the field of physics. He had worked at various national and international research centers and universities like Solar Research Institute, Colorado, USA, Microelectronics Research Center, University of Cambridge, UK. He has chaired countless scientific conferences and is a member of various technical and advisory boards. He had more than 1,000 peer-reviewed publications on his account. As he cannot make it today, but we have Professor Dr. Saira Riaz with us. She can convey his message to us. Professor Dr. Saira Riaz.
Bismillahirrahmanirrahim. Assalamu alaikum and a very good morning to all of you. I'm really very pleased to be here today as a co-chair of the second international conference on emerging trends in physics that has been jointly organized by the Physics Department, Lahore College for Women University and Center of Excellence in Solid State Physics. As it is mentioned that the chief guest of the ceremony, Professor Dr. Shehzad Naseem, HEC Distinguished National Professor, he could not join us due to some unavoidable circumstances, but he will be with us in the next 2 days. So for today, I will read his message for the conference delegates. Assalamu alaikum colleagues. It is a moment of an immense pleasure to see such collaborative activities of international standards. I am proud to see that our young generation is taking an active part in research-based events. It is my pleasure that two of my ex-PhD students, Professor Saira Riaz and Professor Zohra Kiani, are taking research and teaching to the new heights. Arranging technical meetings and conferences is a part of research culture, and it is being done quite efficiently. I wish every success for the career of all attending. I hope it will be a good learning experience for our young scientists as well. Thank you very much.
Thank you, Dr. Saira, and definitely thank you, Dr. Shehzad, for these encouraging words. Now, let's formally start our first session with the permission of our chair, conference chair and conference co-chair. Our first speaker is from University of Agriculture, Faisalabad, Dr. Muhammad Yasin Naz. He is currently serving as a lecturer there. His area of interest is generation and characterization of plasma discharge for the treatment of materials and medical devices, synthesis of nanomaterials using plasma-enhanced chemical vapor deposition technique. Today he is going to share his reviews with us on plastic waste management.
Yeah, Assalamu alaikum. If you hear me, please. Can you hear me, please?
Yes.
Hello?
Yes, sir, we can hear you.
Okay, thank you very much. First of all, I would like to thank the organizers and the participants for sparing the time, and also the organizers who allow us to present our work in this prestigious conference. I'm Dr. Muhammad Yasin Naz from the Department of Physics, University of Agriculture, Faisalabad. So today I will provide you some insight into the plastic waste management through pyrolysis, and we can produce the valuable products using this waste. So actually there are two type of aspects. There is one experimental aspect of this study and one is the theoretical aspect. So having the shortage of the time, I will present only the theoretical aspect of this work. So uh, okay, the content of the presentation includes the introduction and the research gap we addressed in this research, the possible objectives which we made based on our experience, and then the methodology adopted to complete this work. Finally, some results and their possible discussion and the concluding remarks. So as we know that the waste plastics are counted as the non-biodegradable materials and reason for multiple environmental and health issues. These materials are not only harmful for humans but also for aquatic life and wildlife that mistakenly eat these materials, and there would be however, economic development of the the world is also being affected due to the production of the plastic. So the management of plastic waste material is a growing challenge which adversely impacting the environment. So roughly more than 6 billion tons of plastic waste is produced every decade, and out of this bulk amount of the waste, only 9% is recycled, while the 60% is dumped into the landfills and remaining is destroyed or burned. As estimated, roughly 12 billion tons of waste plastic will be accumulated in natural environment by 2025. So it is difficult to process such a huge stock of plastic. A large portion of the waste plastic from environment and plastics, a large portion is being from the developing and underdeveloping countries is burned due to lack of resources and planning and rapidly shrinking landfills capacity. So burning of the plastic means we are wasting a valuable source of energy. So managing the plastic through incineration or burning means we are wasting a valuable hydrocarbon source. Therefore, the sustain the planet's massive population and ecosystem, we have to convert the plastic into valuable products. So the waste plastic is a renewable source of energy, and because synthetic plastics are hydrocarbon rich feedstock, so the hydrogen content of the plastic varies from 88 to 14%. However, this content is difficult to convert it into the desired products. So we have to optimize the processes, especially the experimental processes, to convert this process to the commercial scale. So only 30% is so far recycled waste plastic, and 70% is a challenge which is dumped into the landfill. Therefore, we are working on the statistical analysis to deduce the best conditions which can be helpful in commercializing this process at the large scale. So there are different type of the plastic waste. For example, there are some common kinds of the plastics. They include high density plastic, low density polyethylene plastic, and polyvinyl chloride, and polypropylene and polystyrene. Styrene. So actually there are different type of plastic. So different type of plastic behave in a different way. So at this stage we choose high density plastic, means high density polyethylene, and after this we will go for the mixed plastic because it is a systematic way to find out the best conditions for the commercialization of the process. So in this process, we use high density polyethylene. Why? Because it is the most prevalent solid waste. It has complicated structure and have majority of free electrons, and it has space filling properties and have a very complicated chain structure. So we choose this for the theoretical analysis. So this is the layout of the work and the research gap which we try to address in this work. Actually, first we extracted the experimental reaction rate constants. I mean the reaction rate constants are the constants which drive the reaction during the pyrolysis, and these reactions are very important because they define what kind of product we will obtain at the end of the process. So today, to date, the people perform the experimental analysis to find out the reaction rate constants. So it very less work has been done on the theoretical aspect of this study, because if you do experiments, you are wasting energy and also the money, and then you find the experimental rate constants. And when we try to implement these rate constants at the commercial scale, they didn't meet the requirements, and we cannot get the required efficiency. So the process cannot be cost effective. So here we did this process through statistical analysis. We use the already reported experimental rate constants, and then we try to predict the statistical rate constant using the R software. And then we conducted some sensitivity analysis which have never been conducted in the published literature. Sensitivity analysis means we try to find out the behavior of these reaction rate constants toward the individual products of the pyrolysis, and we check that if we want to get the oil, if we want to get the gas, if we want to get the heavy waxes, if we want to get the light waxes from the pyrolysis, which rate constant is important and which rate constant should be focused for the further study and also for commercialization of the process, which is actually the research gap. We feel that this should be addressed, and we are trying to address this research gap. So, the following objectives were defined. Actually, we are trying to save the time, and we are trying to save the cost to find out the rate constant through statistical analysis, and previously they are normally done through the experimental analysis. And we are trying to depict the ideology concept and trying to translate it into the experimental or commercial scale form. And we are trying to verify the ideological concept through the simulations, and then we implement these through the experiments. So the prime objective, actually, we are trying to find out the effect of activation energy of the reaction, and then frequency factors, temperature, and the reaction rate constants, and their effect on the reaction process. And we are trying to analyze the individual behavior of reaction rate constants towards the final products, which is important aspect, and actually the research gap we are trying to address. So here is the layout of the methodology we adopted to complete this research work. Actually, we extracted the experimental rate constant from the published literature in the first step, and then using these reaction rate constants, we estimated new reaction rate constants, a set of reaction rate constants with slight difference from the experimental rate constants in using our software, and then we use these predicted rate constants in the MATLAB, and we solve the second order differential equations to find out their effect on the oil, gas, heavy waxes, and light wax. Let me clarify you that in this study our focus is the production of maximum amount of the oil, gas, and the second priority is gas. Heavy and light waxes are our third priority, because they need further purification or processing before we can use them for different applications. So here we use the multiple linear regression equations to find out the statistical rate constant, and for slight differences from the experimental rate constant, if we see that we keep the statistical rate constant with a slight difference of 0.02 and 0.03 and 0.04 from the experimental rate constant. And table 1 shows that the extracted values from the statistical model, and we can see that the p-value and p-value shows that the predicted rate constants are valid and we can implement these rate constants in the pyrolysis simulation of the pyrolysis of the plastic layer. And then we use a slight difference of 0.03, and in table 2 we extracted new set of the statistical rate constant, and similarly we use 0.04 difference to find out another set of the reaction rate constant. Here is a complete details of the experimental rate constant which we extracted from the literature. The leftmost column shows that the experimental rate constant actually was taken from the literature, and then the second, third and fourth column towards the right side shows that we predicted three sets of the statistical rate constants with a slight difference of 0.02, 0.03 and 0.04 from the experimental rate constant. Actually, there are 9 reaction rate constants in each step, and these 9 reaction constants collectively affect the reaction of conversion of the plastic into the valuable product. So here is the model pathway. We can see that different rate constant K1 to K9 affect in a different way, and we can say that K1 directly converts the polymer into the low wax. Similarly, the K2 converts the oil polymer into oil, K3 converts the polymer into gas, similarly K4 converts the polymer into heavy waxes, and the other four reaction constants indirectly affect the reaction, and these are the most important because at early stage heavy and light waxes form, which are not our intention. So we want to convert these heavy and light waxes into the oil. So for that, the K8 reaction rate constant is the most important. So here we solve the second order differential equations in the MATLAB, and we try to find out the effect of the reaction rate constant on the heavy waxes, light waxes, oil and gas. So these equation 4 to 8 were used in these analysis to simulate their effect on the product yield and the quality. So in the first analysis simulation, actually we use exactly the experimental rate constant we extracted from the literature, and these reaction rate constants show that after 200 minutes from the start of the process, we get the maximum oil yield of 73.99%, and we get the gas yield of 24.15 seconds after 200 minutes of the process. And we can, if we see at the beginning, initially the light and heavy waxes form in the reaction, and with the passage of the time, these light and heavy waxes convert into the oil and gas. So therefore, their amount with the time decreases, and the amount of oil and waxes increases over time. So these are actually the experimental rate constants. We did not do any change. We used as we received from the literature, and then we use our predicted rate constant. In the first instance, we use the predicted rate constants with a slight difference of 0.02 from the experimental rate constants, and we see that for this difference we get exactly the similar results as in the experimental rate constant. We obtained almost 74% oil and 24.17% gas, and if we go to previous slide, we also get in the experimental case, we get the 74% oil and 24.15% gas. So the results are exactly matching in both cases. But when we go for the difference of 0.03%, in this case our oil production increases and gas production decreases, while the light and heavy waxes behave in the same way as in the previous case. Our oil increased from 74% to 78.44% and gas reduced from 24% to 20.72%. It shows that as the gas reduces means light and heavy waxes are not converting too much into the gas, but they are converting into the oil. So oil content increase. So these rate constants predicted statistically with a difference of 0.03 from the experimental rate constant produce best result if you want to commercialize this process for future incineration of the or valorization of the plastic into the valuable product. So then we use our difference of 0.04 from the experimental rate constant. Again, we see that we find the same results as we obtained in the experimental case. So these differences show that 0.03 difference is the best for the production of the maximum oil from the pyrolysis of the plastic. And then we conducted the sensitivity analysis, and sensitivity means that how the individual rate constants can affect the reaction to produce a specific product. I mean, we can ensure the selectivity of the product through this process. And here, because only the K8 rate constant, the second last rate constant out of the 9 we produced through statistical analysis, K8 is the most important in this process, and it affected the oil yield most as compared to the other rate constants. So having the shortage of the time, I just added the analysis of the K8 reaction rate constant. As we see that the oil yield using this rate constant further increased from 74% to 79.18%, and it shows that the light wax decreased over time. It means if we focus on this rate constant, it converts the light wax into the oil, and light wax, I already mentioned, it is an actually unwanted product in our case. So it minimizes the wax production and maximize the oil production. So this is the best parameter to consider if we want to extend the process or scale up the process for the bulk conversion of the plastic into the valuable product. So here are the actual conclusions. What we did, we conducted statistical analysis on the reaction rate constant for the pyrolysis of the plastic into the valuable fuels, and then we find out that 0.03 difference of the statistical rate constant from the experimental rate constant produce the best results for the production of the oil, and the K8 rate constant out of the set of 9 rate constants produce the best result for the oil production and produce the minimum waxes when we wanna focus on the oil production. So the K8 rate constant and the statistical predicted rate constant with the 0.03 difference will produce the best result. But this work has some limitations. Actually, we should also highlight these limitations. Actually, I mentioned in methodology, we just focus on one type of the plastic, I mean the high density polyethylene. But when we practically try to implement such process, we find that there is a mixed type of the plastics. I mean, there are high density plastic, low density polyethylene, polystyrene, and many other types of the plastic. So at the moment we just focus on one type of the plastic. If we wanna make the process a success in the future, we have to reconsider the simulations for the mixed type of the plastic, and actually it would be our future undertaking. So this is only one the limitation of our process. So thank you very much. I am open for questions.
Thank you so much, sir.
Hello.
Yes, sir, thank you so much. Is there
Hello.
any question from the audience?
Hello.
Yes, sir, we can hear you.
जी
सर हम आपको सुन सकते हैं
जी 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 थैंक यू Any question, please? I have finished my presentation.
Thank you so much, sir.
Dear Madam Hina Nazli, if there is any question, please let me know. Otherwise, I have finished my presentation.
Assalamualaikum sir. There is no question. Thank you very much for your talk and for your precious time.
Thank you.
Please stay with us.
Thank you. Thank you.
Thank you so much, sir, for your talk. Now, I would like to request Dr. Shahid Ateek and Dr. Sajjad from Center for Advanced Studies in Physics to come on stage and kindly, sir, you will be heading our next session.
Okay, next speaker of this session is Dr. Abdul Ghaffar. He is serving as associate professor at University of Agriculture, Faisalabad. He is working on light interaction with plasma coated surfaces, radiative responses of thin films, plasma propagation, antenna arrays for 5G technology, and electromagnetic wave theory. Dr. Ghaffar is discussing, the title of his today's talk is Electromagnetic Surface Waves and Their Applications. So let's welcome Dr. Abdul Ghaffar to present his today's talk.
Assalamu alaikum. Dr. Abdul Ghaffar sir, kindly please share your screen.
Bismillahirrahmanirrahim. First of all, I am thankful to the organizing team for the second international conference, Emerging Trends in Physics, in the Department of Physics, Lahore College for Women, University, Lahore. The title of my talk is Electromagnetic Surface Wave and Their Applications. First of all, I will give you outline about my talk. Introduction, taxonomy of EM wave, EM surface wave, surface plasmon claritone, excitation of surface wave, and application of surface wave. Are you hearing me, Dr. Hina?
Yes, sir, we can hear you.
Yes, sir, we can hear you. Please continue.
First of all, I will introduce the electromagnetic surface wave. Electromagnetic surface wave which propagate along the interface between two dissimilar media is known as EM surface wave. Here, this is the schematic view of dielectric metal interface, medium 1 and medium 2. So, basic condition for the propagation of surface wave, it should propagate along the interface. This is the interface between two media. Its amplitude decreases exponentially as move away from the surface or interface. There are different types of surface wave. First of all, surface wave between two dissimilar media such as dielectric and matter. Such type of waves are known as surface plasmon claritone wave. and second one is in between anisotropic dielectric media and isotropic dielectric media. This kind of wave is known as Deknov wave. And third one is TAM wave, which occurs between periodically non-homogeneous dielectric and isotropic dielectric media. Third one and fourth one is Dekhanov TAM wave, which occurs between periodically non-homogeneous anisotropic dielectric and anisotropic dielectric media. And the fifth one is non-linear type materials, in which this type of wave occurs between non-linear media. And the sixth one is chiral surface wave that will propagate between isotropic chiral media and isotropic metals. And the seventh one is magnetic surface wave, which occurs which propagates between isotropic dielectric media and periodically non-homogeneous magnetic media. So, if we study in these waves, first of all, surface plasmon plericon occur between metal and dielectric. It has two modes, and its characteristic is it excitable by p-polarized plane wave. No direct excitation occurs. Second one is Dekhanov wave. It propagates between homogeneous dielectric media and homogeneous anisotropic dielectric media. This type of surface wave have more than one modes, and this can be excitable by S and P polarized plane wave, and it can be excited by possible experimental demonstrations. Third one is TAM wave, which propagate between homogeneous isotropic dielectric media and periodically non-homogeneous isotropic media. This type of wave also have more than one modes, and this can also be excitable by both surface S and P polarized, and it can be excitable by possible experimental demonstrations. Third one, Dekhanov TAM wave, they occurs between anisotropic dielectric and periodically non-homogeneous anisotropic having more than one mode. All these surface plasmon waves have more than one modes, and this and can be excited by S and P polarized excitation and experimentally except magnetic surface wave. So surface plasmon plericon, first type. In this type, electromagnetic wave which propagate along interface between dielectric and metal interface is known as surface plasmon plericon. Here is above one media is dielectric and below one is metals. The surface wave propagate between these two media. So this type of surface wave couples oscillation of plasmon and photon. If we see in this figures, here below is metal and above is dielectric. These are the positive and negative charge. These are the coupled oscillation of plasmon and plericon, and these are known as surface plasmon plericon, which are known as SPP waves. We divide our problems first into two categories. First of all, analytical modeling, and secondly, numerical modeling. Analytical modeling, we have canonical boundary value problem, and numerical coding is done in Mathematica. So, we take Joule model to compute permittivity of metal and dielectric. After that, we use Maxwell equations to model the electromagnetic response and to find out the field equations. After getting these field equations, we will obtain the wave equation, which will be used to model the EM wave and after that we will apply, we apply boundary conditions to study the behavior of electromagnetic wave between or at the interfaces. After, by applying boundary conditions, we get dispersion equation to find out the EM coupling and surface wave conditions. This is the analytical methodology of our model, and then when we have obtained dispersion equations, we will use numerical methodology to obtain the characteristic of surface waves. So we will use Mathematica for numerical coding. To find out the numerical coding, we use we can find out the dispersion curve, field distribution, and characteristic of surface wave. This is the flow chart of our work. Field phasor, first of all, TM field phasors, these are in the form of plane wave, and transverse electric wave does not support surface plasmon polaritones, whereas TM wave supports the surface plasmon polaritones. Here we have taken two media, first is metal and second one is dielectric, that is metal is gold and dielectric is silica, which have permittivity epsilon 1 and epsilon 2. Electromagnetic surface wave propagate in the x directions. So first of all we will find out the phasor equations. To find out the phasor equation for the medium greater than 0, that is known as dielectric. Here we are taking TM wave. So in y directions, y component of magnetic fields, we have this type of equations, and then we apply Maxwell equation, we will obtain electric field components in x and z directions. Here the electromagnetic surface wave is propagating in x direction. In the second one media is metal, in which is less than z directions. Here we will obtain the field equations of the metals, and by for TM wave propagations, here K1 and K2 are the numbers in wave numbers in metals and dielectric, whereas beta, epsilon 1 and epsilon 2 are the combined propagation constant for surface plasmon polaritone wave, permittivity of metal and dielectric respectively. Then after finding the phasor equations, we use boundary conditions. We are using two media which are separating at z is equal to 0. So for z is equal to 0, we use boundary conditions for in the form of these: Exm is equal to Exd, Hym is equal to Hyd. From these equations, we will get this type of relations, and from this, by solving these equations and by putting the value of K1 and K2 in the dispersion relation obtained in this box, we will get the dispersion relation, which is known as characteristic equation of the surface plasmon polaritone between two dissimilar media, that is dielectric. One is the silica and the second is gold, metal is gold. So characteristic of surface plasmon polaritone, first of all we obtained dispersion relations, field distribution, and then we numerically we will obtain the propagation length, effective mode index, phase velocity and group velocity. This is the electric oscillation of electron plasmon near surface. So no propagation electrostatic modes occurs. Here is the dispersion relations between normalized frequency and normalized propagation constant. So this is the below this media where is the surface plasmon plaritone. Here is the this is we divide the region in three regions. One is the surface plasmon, second one is the forbidden regions, which is between omega p and omega sp. So omega is the operating frequency and omega p is the plasma frequency, and the omega sp is the surface plasmon frequency. So this is the propagation constant with respect to the frequency. So we see that here we in the propagation we can get the cutoff frequency of the surface plasmon in this characteristic relations or dispersion relations. These are the phasor field, normalized field component in z direction. We are taking along z axis. So this phasor relation show that as we move away from the interface, the amplitude starts decreasing exponentially, which confirm basic condition of surface wave. This is the physical meaning of this field and which fulfill the conditions of surface plasmon claritones. This is the second one result, which is effective mode index. Effective mode index is the beta over k naught with respect to normalized frequency. This result show that it measures the confinement of surface wave on combined interface between metal and dielectric, which confirms the practical applicability of structure. This is the propagation length versus frequency, and it defines the distance of propagation at which intensity of wave becomes 1 over E, provide the dimension of range of SPP based structures. This is the results of group phase group. This is the results of and phase velocity, group and phase velocity, speed of SPP wave with respect to frequency. So this equation and these results show that at this frequency no propagating mode occurs. This is from at this frequency 8 into 10 raised to power 15 hertz. So electrostatic mode occurs, will start. So the propagation mode is till 7 into 10 raised to power 15. This is the simulation of surface plasmon wave, and we can excite the surface plasmon wave by these four methods: prism coupled methods, near spectroscopy optical method, probe method, grating methods, diffraction methods. Now we will describe one by one these methods. Prism coupled methods. In this method, electromagnetic wave enters to the prism and hit the metals, and then at the metals and prism the surface wave will occur between the two medias. And second one is auto configurations. Here we have two media, dielectric and metals. The prism is placed above the dielectric and we hit the electromagnetic waves from one side of the prism, and it will pass through the prism, and after reflection into the prism will pass out, and the surface wave will occur between dielectric and metal interface. This is known as auto configurations, and these are prism coupled configurations. These are used for the phase matching and momentum transferring mechanism which is required to excite the surface plasmon claritone waves. This is the near field optical microscope probe configurations. In this configuration, we can these configurations are used for direct excitation of surface wave near to the surface, examine chemical sensing. Here, in this wave, we apply the scanning probe laser and can find out the chemicals sensing. This is the diffraction grating methods, and the one is the diffraction method and second one is the grating methods. Here is a metal, above the metal we have grating, and incidents and reflected wave pass through this metal and diffraction will occur. Due to this diffraction, metals and dielectric interaction interfaces, the surface wave will produce. Similarly, this is the grating methods. So these surface plasmon waves, surface plasmon polariton have different applications such as optical and biosensing, communications, plasmonic waveguides, spectroscopy, and image processing. We have done a lot of work in these fields. I have produced more than 7 PhD students and more than 50 MPhil students, and they are publishing and working a lot of work. We have published more than 250 papers in the surface plasmon polariton, and this is the very emerging fields in nowadays, and it can interact, it can benefit the student without going to anywhere, and it is only lab work. We do the analytical modeling and then numerical computational methods. So this one is the optical biosensing applications of surface plasmon polariton. From this we will get chemical sensing and biosensing. This is the surface plasmon based communications. This application is done on chip communication methods. So this is the plasmonic wave guides which are used in electromagnetics, are in the defense technology. So these are the surface plasmon SPR spectroscopy and imaging. So these are the key applications of the surface plasmon polaritons. Thank you very much. If you have any questions, please.
Thank you so much, sir, for your talk. Is there any question from the audience?
Dr. Hina,
Sir,
are you listening me?
yes, we can listen you. Sir,
Hello?
yes, we can hear
Hello.
Is there any problem?
you.
Hello?
Yes, we can hear you, sir.
Hello?
Hello.
Yes, Dr. Hina, please.
Yes, Dr. Saab, thank you very much for your talk. We can listen you. There is a technical problem, that's why you can listen us.
Okay, thank you very much.
Anyhow, thank you very much for your words and for your nice talks.
Yes, thank you so much, sir. Is there any question from the audience? I think there is no question. Thank you, sir, for your talk. Now, thank you so much, Dr. Shahid Atiq and Dr. Sajjad for sessioning our chair. Now, I would like to invite our guests in front of the stage for the group photo. Guests and participants kindly gather in front of the stage for the group photo.